In this video, we are going to use matrices to find the equation of a parabola when we are given 3 points on the parabola. We don't know anything about these points other than that they exist. So what we're going to be working with is a standard form equation. I'm going to think of the standard form as ax squared plus bx plus c equals y, instead of y equals, and I'll kind of explain that more when we get into actually writing our matrix. Before we can get to the matrix, we have to write a system of equations. There's going to be 3 equations, 1 for each ordered pair. The weird part about this is you've been using x and y as your variables pretty much since you learned what a variable was. But in this problem, x and y are our constant values, and a, b, and c are our variable values. So what I mean by that is for this red -1, 5, I'm going to have a times -1 squared plus -1 times b, I'll put b first, plus c equals 5 for my y value. So effectively, I actually have 1a minus 1b plus 1c equals 5. I do the same thing for the green. If x is 0, I have a times 0 squared plus b times 0 plus the c is just c equals 3, which is effectively the equation c equals 3. I'm going to write 0a plus 0b plus c equals 3, just for when we get to the matrix part. And then in the blue one, I'm going to have a times 3 squared plus b times 3 plus c is equal to 9 when I plug in x and y. That gives me 9a plus 3b plus 1c equals 9. Now I'm going to take these 3 lines, stack them on top of each other. So I'm going to have 1a minus 1b plus 1c equals 5. 0a plus 0b plus 1c equals 3. And 9, I don't know why I wrote y's there. My brain went absolutely crazy. 9a plus 3b plus 1c. I don't know why I wrote a y there. Apologize if that made you lose your mind for a second. But I should have 9a plus 3b plus 1c equals 9. Here's my system of equations. In our matrix unit, we talked about making an augmented matrix. That's what we're going to do here. We're going to take our coefficients of each variable. So in the red, I'm going to have a 1, -1, 1, and then that all ended up equaling 5. In the green, I'm going to have a 0, a 0, a 1, and that ends up equaling 3. We should know our end result here, c is going to be 3 because of this specific line. And in the last blue one, I have a 9, a 3, a 1, and a 9. Here is my augmented matrix. This is what I want to put in my calculator. So I again go to second matrix, over to edit whichever matrix I want. I'm going to use A. This is a 3x4 matrix. All right, so remember, I have to set this up as a 3x4 matrix, 3 rows, 4 columns. I type in all my numbers, make sure I use my negative signs. This is where I needed those zeros in that green line. And then after I do that, I quit back out, so second quit. And I go second matrix, I scroll over to math, and then either up or down to RREF. That stands for reduced row echelon form. Second matrix, pick the matrix that I just put in, that augmented matrix. That's going to give me 1, 0, 0, 1, 0, 1, 0, -1, 0, 0, 1, 3, which tells me A is 1, B is -1, and C is 3. Okay, the first column is the A values, second is B, and the third is C. So A, B, C, top to bottom, 1, -1, and 3. So in standard form, I'm going to have 1x squared minus 1x plus 3. I put y equals here. I could have put equals y. I could have put f of x. That would have been fine. Also, y equals 1x squared minus 1x plus 3. This is the longest process for if you have to find the equation of a parabola given ordered pairs. Have a great day, everybody.